Good evening, my YouTube viewers. In this video is going to be a second practice question, and the practice question is going to concern a confidence interval for mean. So the question is, the average height of a random sample of 50 apples, or that's the average weight of a random sample of 50 apples, is 150 grams with a standard deviation of 10 grams. Calculate the 95% confidence interval for the average weight of the apples in the population. So we're going to answer this question writing a program in Python. And so in order to write the program in Python, we have to import our libraries, and the libraries help the program to execute. The reason why is because Python is a generic language and it does not have these functions written into the program, so we have to use libraries to get access to the functions. So the first library that we're going to import is NumPy as NP, which is the numeric library. The second library that we're going to import is SciPy.stats as stats. So stats is the statistics module in SciPy, and SciPy is a scientific library. And the third library that we're going to import is matplotlib.pyplot SPLT, which is the visualization library. So now what we are going to do is we're going to define our variables. So sample mean is 150, sample standard deviation is 10, sample size is 50, and confidence level is 95%. And then we're going to calculate our standard error. So the standard error equals the sample standard deviation divided by the square root of the sample size, and that is your standard error. We're going to find the T critical value for 95% confidence interval. Degrees of freedom equals sample size minus 1, so that's 49. T critical equals stats.t.ppf brackets 1 plus confidence level divided by 2, comma, degree of df equals degree of freedom. So ppf is like a percentage point function. So we're going to calculate the confidence interval. Margin of error equals T critical times standard error. And then lower bound equals the sample mean plus margin of error, and the upper is sample mean minus margin of error, and the upper bound is sample mean plus margin of error. So we're going to print the confidence interval. So the confidence interval with a mean of 150 grams is 147.16 to 152.84. And so we're going to put the confidence intervals on a graph. So plt.figure brackets fig size equals 6, 4. And then we're going to plot a vertical line on the graph. plt.ax fig line bracket sample mean, comma, color equals blue, comma, line style equals dashed, comma, line width equals 2, comma, label equals sample mean in grams. And then you've got plt.ax feed line brackets upper bound, comma, color equals green, comma, line style equals dashed, comma, line width equals 1.5, comma, label equals lower bound grams. Then you've got plt.ax feed line brackets upper bound, comma, color equals red, comma, line style equals dashed, comma, line width equals 1.5, comma, label equals upper bound, grams. And I just wanted to check something really quickly. So now we're going to annotate the graph. So the title is 95% confidence interval for apple weights. The X label is weight in grams. The Y label is density. You get a legend and you get a grid, and we're going to show it. And when we show it, we have a 95% confidence interval for apple weights. So we didn't get a histogram in it this time because we didn't make a histogram, but the sample mean is 150 grams. Lower bounds is 147.16 grams, and upper bound is 152.84. So that's the confidence interval for a mean of 150 grams. So this is going to conclude our video. The next video is going to be proportion estimation, and I hope you decide to watch it.